So now I want to show you a realistic investigation. We're going to infect the Windows machine and then analyze that infection remotely through Velociraptor. So we're going to infect it with this pup. And so the easiest way to do that is to open the instructions on the Windows machine. So let's go here. All right, so we go into my page here and open the forensics and projects. And it's the third project here, 372. PUP is a potentially unwanted program, and I just wrote a simple script that will do some nasty things to the machine to act like a really simple infection. So to infect the machine, first you have to turn off Windows Defender. And so I have separate instructions for Windows 10 and Windows 11 because Microsoft always has to make everything annoying and difficult. But anyway, I figured out how to do it. So next to the Start button, search for virus. Let's see if that works. All right, virus and threat protection. That's good. And I guess I'll go to the instructions out here while it's loading there. All right, so virus and threat protection. Manage settings, okay. Okay, manage settings here. And turn off tamper protection, which will keep undoing the changes we make, okay. And now go to exclusions and exclude the whole C drive. So I approve the elevation of privilege, add or remove exclusions, approve the elevation of privilege, and now I add an exclusion. That's going to be a folder, and the folder is going to be the whole C drive. So it will no longer complain about malware anywhere on this machine. That's why you use a virtual machine. You don't want to do this to a real machine you love. And now we're going to turn off cloud delivered protection and automatic sample submission. So I'll go back. Whoa, I missed. Whoops. I did D by accident. That's not going to do it. D is like the CD-ROM. Here's my exclusions. Add or remove exclusions. And yep, D. That's not what I want. I want C. Oh, I have to expand this PC. Now I can click C. Okay, good. All right. Now it's going to ignore any malware it finds. And now I'm going to turn off those other things. It was cloud delivered and automatic sample. Okay, cloud delivered is here, an automatic sample. And it keeps asking me to elevate to administrator to turn these things off. Okay, so now I've turned off Windows Defender, so it's not going to complain all the time about my malware. Now we're going to install the PUP. So all you do is you download this thing, a zip file. Okay, now you open it. You go to your downloads folder. You have to extract it. So you it's a zip file. You right click, extract all, extract. And what you always do if in the way malware is properly handled is you zip it and you put a password on it. So nobody will unzip it by accident. And the password is malware. This is the standard in the business. Whenever you get malware samples, this is typically how they're distributed. So nobody will accidentally infect anything with them. You clearly know it's malware and you're doing it deliberately. So now it's unzipped. There's a PUP4 folder. And in there's a couple of files, PUP4 and PUP4 message and a couple other things. So now, after you've got it, now you run PUP4 as administrator. So I right-click this and run as administrator. That's the script that does a few changes. And again, it warns me this doesn't look good, and you have to override it and run anyway. Then it elevates to administrator to make some registry changes on your machine. Okay, there it opened up a box and ran some commands. And now, the next step is the PUP4 message should be in the root of C. So you drag that and drop it on the root of C. And again, you're going to have to approve that. Okay, and then you clean up all the tracks. You go back to downloads and you delete this. Delete PUP4, which should be a little picture of a trash can. Yeah, it's up here. Delete. Okay. And then you delete this. Again, there should be there we are. There's the trash can. And then you empty the trash can. This is what, so all evidence of it should be gone. Or at least most evidence of empty recycle bin. There. So now the only thing left is that thing I put in the root of C. And now you restart this machine, and it should show signs of infection. And it's going to turn out that there's yet another Windows defense we have to bypass. So, you know, this is what you get when I write really sloppy malware. The installation process is not easy, and it would never fool anybody. But anyway, it accomplishes our goal, which is to create a common kind of infection so you can analyze it from a distance.
So, Sam, when you infect a virtual machine,
Yeah.
it is enough to restart the virtual machine to get rid of the infection, or
No.
you have to uninstall the virtual machine and reinstall?
Well, you have to clean it off. Now, reinstalling it is one way to clean it off, but normally you don't want to put up with that, especially in a company environment. You want to figure out how to remove the malware, and that's what we're going to do. You'd rather just clean it off without having to rebuild the machine. Although, if you have a good image-based backup, that's often the best thing. Just go to a clean image.
Okay.
In this case, I don't. So, all right, now I'm going to log in again with my password. All right, so now when you restart the machine, it's going to launch the malware, and it's going to give you a box warning you that something funny is launching. Yep, so the publisher could not be verified. Are you sure you want to run it? So clear this box saying always ask and approve the running. And now it will never ask again. It runs the malware, and what the malware does is, that's annoying. Okay, here's another problem that happened to me before. That's right, it uses Microsoft Visual C++ just redistributable, which is normally included with Windows, but I remember the problem. I wrote it to compile to 32-bit code. And even though Microsoft 64-bit operating systems support 32-bit code, they don't have this library by default. So if that happens, then you have to search for Microsoft Visual C++ redistributable download and get the 32-bit version. So
The x86, right?
yeah, that's right. And that's why it didn't find it. So I'm not going to do that. I'm going to search for that. Microsoft Visual C++ redistributable download. There it is. And there's going to be a 32-bit version available.
I think you can click, because I did it.
First one here, I think.
Scroll a little bit down. Yeah, that one.
Yeah, the first one is the latest one, which is fine. I don't think it makes any difference. Okay, latest version. There we are. Here we are. And there you are. Let me make this font bigger if I can. Yeah, so there's the 32-bit version. That's what we need. And I think it is downloading. It's just that somehow I've got this thing zoomed in too much. How do I make it? There we are. Good. Okay, there it downloaded it. I can open the file here and just run the installer. Okay, I agree to the license. Install. Yes. Okay. Successful. All right. So now, if I restart the machine, it should launch the malware. Let's see if that works. This is why I wanted to make sure and do it with all the problems that crop up, so students hopefully don't get stuck so much. There are a lot of little problems.
So the .dll refers to the virtual, the redistributable.
Yeah, it didn't have the 32-bit DIL to run .NET programs, which I think it did include in earlier versions of Windows, but anyway. All right, so now I relog into my machine. Now it should run the malware and pop up an irritating box. That's what this malware does. Okay, it's still loading. Yep, there it goes. Your machine is pwned. That's what it does. It pops up a box with this message, your computer is pwned by Double Bad. So that's all. This is, punk malware. But anyway, the point is, the situation is now, people get infected, they're at your company, they say, hey, I got a problem, this weird box pops up. And now you want to investigate that, but not on the Windows machine. You want to investigate it remotely from Linux. That's the idea. We're going to investigate this incident. So the first thing, of course, you should have your Linux machine connected to your Windows machine, and we do. If I go here to show all, there it is. I'm still connected to that Windows machine because I didn't uninstall the Velociraptor client or anything, so I'm able to interrogate the Windows machine. So now I know that something automatically launches every time the machine restarts. So the first thing I'm going to run is AutoRuns, which is a sysinternals tool from Microsoft that shows you everything that automatically launches on this machine. So that's a simple one. So let's do that. I go to collected and plus, and I search for auto runs. And there it is, Windows sysinternal auto runs. And I think, again, at first I struggled a lot here, worrying about how I was going to get the ARM version of auto runs to go, and then I realized I just don't care. I can run the Intel version of auto runs on a Windows on ARM, and it'll run. Just like I'm running the Intel Velociraptor client on a Windows with ARM, and it runs. So that's good. I don't have to worry about it. I can just launch it without changing the parameters. Again, this means scheduled, but it shouldn't take too long before it actually runs. And if I look at the log, I should see, there it is, shows a picture of Bill of Running Man. Here it is doing things. So it removes some temp file. It's going to download the auto runs from my Velociraptor server. It's put it on there, and it's going to download it, and it's going to check the hash to make sure it gets a good download. Then it's going to run the installer and install it on the Windows machine. And then it's going to execute it and collect all the data from it. So it's really pretty awesome. And by the way, as you can see, really dangerous. You know, I really have total control of that Windows machine. I can install software, I can download files from it and everything. So, you know, you really wouldn't want an untrusted person using this. It'd be just like a rat, remote access Trojan. So it's done. So if I go to results, here it is, and it has 1,356 rows. There are 1,356 things that automatically launch on this Windows machine. So that's a little bit annoying. How am I going to find the one that matters out of all that? What I'm going to do, since I got a lot of those, is you can download a CSV file with this button here. And then you can put it in like a spreadsheet or something and search through it. That's what we're going to do. We're going to download the CSV, and we're going to find the run key, because it automatically launches, and the most common way to make something launch is to change this registry key. HKey local machine software, and then current version run. There's run keys. There's a variety of these that automatically run things. So I'm going to download the CSV, which is here. And there it is. That's the download is complete. And now I can open it on this machine. I could open it in a text editor. I think I'll just do that. I'll open it with my text editor. One I like is Smeltron. All right, so there it is. I now got all this junk. And now, let me see what I said in the instructions to do here. I say open it and find the run key used to launch PUP4 message. So what I do, to be sort of realistic of what you have to do now, is I search for, say, run. Now, there's another thing you could do, by the way. Let me show you something else to be a little more realistic. Let's open that CSV in a spreadsheet. If I double-click it, it should launch in the Apple default spreadsheet. Okay, notice that there's, let's get rid of the format. Okay, let's move over. There's description, and there's company. This is what's useful. The company name is what company signed this stuff. Okay, and let me zoom in here. Make this easier for people to see remotely. All right, the company is the signer. And notice some of them have not been signed. It's blank. Those are the suspicious ones. Things that are signed by Microsoft, that's probably not malware. So if you wanted to find it in a sort of realistic way, what you do is sort this. So I go to organize. I got to select everything. Okay, select everything, then organize. Okay, now I'm going to sort the entire table by company, or not category, but company. There. Now I've sorted the whole table by company, so the ones that don't have the company should be all in one place at either the top or the bottom. There's the company, looks like it's the bottom. So I'll scroll down to the bottom. I can probably use a special keystroke to get there. There, I'm now at the end of the ones. So I had like 1,200 of these, but 1,357 of them are signed. Here's the unsigned ones. Let's see. All right, let me get to the top again. I'm having trouble. The company is column I. Okay. I'll go to the bottom of column I. Okay, here I am. These are the ones with no company. And there's not that many of them. And so now, here's the file that was run. Some of them, it couldn't find the file, so it didn't really launch it. But here's all the ones that are not signed. And so I can look through here to see if I find anything meaningful. And here's a bunch of Windows DIL files. Those look like Microsoft products. And here's one that looks funny. It's an executable in the root of C where nothing should be, and it's not signed. So that's how, realistically, you can figure out that this is probably the problem. This thing called pup4message.exe in the root of C is not signed and it's launching automatically. That looks suspicious. So that's how I make my first step of the investigation, where I have a suspect that this might be the problem, but I'm not sure yet. Okay, so that's the first step. And now I can find the run key that launched it here. That'll be in this line somewhere. It'll show you why it launched, and here's why it launched. It's in this Microsoft Windows current version run key, which is one of the keys that automatically launches software every time you restart the machine. So that's why it's launching, and I see where the executable is, so now I would like to learn more about it. So next thing, I might want to get the MD5 of that executable so I can send it up to VirusTotal or something and see if this is known malware. So I can do that with PSList. So I go here and do another collection for PSList, Windows System PSList. Now this will give me a list of all running processes. Now since 1,341 things are launching automatically, they're probably all running, so I really don't want to get all those. What I'm going to do is limit the name. Now I know the name of it is pup4message.exe. So I can go and I don't need to see every running process. I want to learn about this process. So there is a process regex. And I can just put in pup. It has a name pup4message, so it'll only show me processes that contain the word pup. That should not be a big list anymore. Now I launch, it's waiting to run, it's done. Okay, and it only found one thing, one row came back, so that's more like it. So here's the name, pup4message.exe, here's the command line, here's the information about it, and here's the hash, the MD5 and the SHA-1 hash. So that's useful. Now I could send that off to VirusTotal or something and see if this is known malware. Now I could record it in my notes. This is the identifier of the particular file that's infected this machine, or so I suspect. I still have not proven that this is the source of that message. I've just found something that looked funny, and I got its hash. Now to prove that it's the one launching the message, I'm going to get the memory of that process with process dump, which is pretty awesome, because I know the message says pwned by double bad. So that should be in the process memory. So let's get process memory. Process, Windows memory process dump. That's it. Okay. And now once again, I don't want all the processes. I want the ones with a name that includes the word pup. So I put in pup. All right, and then I'll run that. And so it's going to connect to the machine and find the memory and put it in a file and send it back to me over the network. So it took a little while, but it appears to be done. Here's the results. And what it's going to have done is uploaded a file. And there it is. This is the file, which is the memory dump from that machine. Now I can analyze that in various ways. The way I did it before was by moving it to the Debian machine for analysis. And by the way, I think it's probably already on the Debian machine. One thing I didn't put in the instructions, but from the previous one, I think the same trick would work. Let's get to the instructions for the previous project. I didn't think of this at the time, but remember how we made the MSI file and found that it was already on the Debian machine. This file is probably also on the machine. So there was a this canned, there. Sudo find pipe grep, it's probably already on the machine. Let's see if I can find it. I'll go to my, okay, clear. Okay, so I'm going to search for something called .dump. DMP, I guess, that might do it. Okay. There it is. It's already on the machine. Okay, in some stupid vartemp velociraptor folder. Okay, so now I can analyze it, and I just want to see the readable strings in it. Now, the strings command is useful. If I don't have it, I should be able to install it. Sudo apt install strings. Oh, phooey. All right, well, I see the defect in my instructions. We have to install strings on Debian. Oh, it's here. Install binutils. Good. Okay, good. Binutils. Good. All right. Now I have strings. So I can run strings on that stupid thing. And you see, Oh, it didn't find it. Well, now that's rude. No such file. Well, let me do that find again, and let's see what went wrong here. I do the find, and there it is. Okay, what I'm going to do is, oh, it has spaces in the name, that's why. Okay, so I'm going to move this file somewhere easier to deal with, like my current directory. So I'm going to copy that file and put it in the current directory called mem.dump. And the thing is, if there are spaces, I need to backslash the spaces. That's here. I think that's the only one. Yep. Now if I do ls-l, there it is, mem.dump. Now I can run strings on mem.dump. And I see a lot of readable strings. Okay, but I wanted to see the word pwned. And it's not there. Oh, grep pwned. And it's not there, but the reason it's not there is because Microsoft doesn't use ASCII very much. They use 16-bit Unicode because they're an international operating system. And for that, you need to use the -EL switch to look for long characters. And now you find those messages. So now we have proven that that running process is the one that printed that message because we found the message in there. So now we know what process is making the visible message. And the next question is, are there other files on this machine that are part of the infection? So we're going to use Yara for that. Yara is a tool that scans through files and tries to match them with a pattern. It's just sort of like grep. So we're going to use Yara to see if there are any other files on the Windows machine that contain the word pwned, which is not a normal word and shouldn't be in any normal file. So we Windows search Yara plus Yara. And there it is, Windows search. Well, a lot of Yaras. Windows search Yara. That's the one. And again, I can configure parameters. And there's two things to configure. One is what kind of files I'm going to look in, and the other is what I'm looking for. The keyword I'm going to look for is pwned. Get rid of this. And by the way, I know it's capital, and I know it's using wide characters, not ASCII. So I can simplify the search by getting rid of no case and getting rid of ASCII. I could leave it there and it would be harmless, it would just waste a little time. And now I could look in EXEs, text, DILs, and PHPs, but the only thing I care about is EXEs. I'm trying to find the executable that infected this machine. So I'm going to get rid of this and that there. I'm just going to look at every EXE on the whole box and see if it contains this word. Now I launched that. So it has to traverse the entire Windows box. So it'll take a little while, but not too long. You can see it here, directly scanning these files, all these different EXEs. And might take a minute, but it won't take too long. Because the one that's running, popping up that box, might not be the only one on the machine that's part of this. Okay, now it's done. So I look at my results, and the only thing it found was the run in the root of C, pup4 message, because remember, we deleted the others. So there are, in fact, no other files on the machine that appear to be part of the infection.
That have pwned.
That's right, they have pwned in it. They could, so it's not a very thorough test. There could be other things. It might be better to take the creation date of this file and get all the things that were put there like within the last 5 minutes or something. That might be a better test, that kind of thing. Yep, that's right, you can do that too. All right, then anyway, so now we've analyzed it. Now we're going to try and clean it off. Now, Velociraptor, now that I know what's going on, I know how to clean it. I need to kill the running task, which is pup4 message. You need to delete that registry key, the run key that makes it automatically launch, and then delete that executable. Those are the three things that will get it off the machine. Now, you can run commands on the client one by one here. If you go up here and click the name of your desktop, now you can click shell. And you can have either PowerShell or CMD, or this Velociraptor query language, which I don't know. These are two. You can run commands on here one by one. So, for example, let's start with like netstat or ipconfig, a familiar command. If I run that in, say, CMD and launch it, then it appears down here, and if I want to see the answer, I click the I. And there's the answer. So I can run a command and I can see the answer. That's what's going on. So the commands that will clean this box are task kill, the image named PUP4. That should terminate the running process. So let's take a look at the Windows box and see the desktop. There's that thing sitting there. Let me move this to the right so we can see the desktop while I do this. If it works, it'll kill that box. So I'm going to run that here. Task kill PUP4 message. So launch. And it didn't kill it. And when I show the logs, here's the logs, starting query execution, and looks like it seemed to run, but it didn't actually do the job. I found this for quite a few of these. Now, I think what's going on, there's some discussion in the Velociraptor developers forum where they talk about this. They're kind of worried about this functionality being too powerful. So I think they've limited what it can do to some extent. So you find that some of the things don't work in this environment. Anyway, that's what I found. You can't really clean it off this way. You can see, but you will find a flag here. If you're in the registry, see what happens. You can, some of these commands work and others don't. So you can't really clean it off, but you do get to see this interactive command running thing for what it's worth. And to really remediate it, you have to go execute those commands locally on the machine the same way you infected it. So I'll just do that to finish up my demo. So now I'll open it up here. I'll just get those commands here by opening the instructions on this machine the easy way. I could probably copy and paste them from the other one, actually, since I have VMware Tools, copy and paste is working. Yeah, I'll just do that. That's a little classier. So all I need is a administrator command prompt, I think. Let me check. Administrator command prompt. Okay, CMD. And yes, run as administrator should be an option. There it comes. Okay. All right. There we go. All right. So the first command is this task kill. Copy that. I want to move it so I can see the box. There it is. I paste it and run it. And that kills the box. Now the box goes away. So it's success. It terminated the process. So now I get rid of the box. Now I delete the registry key so it will stop automatically launching every time I restart the machine. Okay, and I can make the font bigger here. Let me do that. Font. There we go. All right. So I'll delete the registry key. Oh, that's rude. Reg delete. I think that's slash at the end. Oh, /F. I'm missing an F at the end. F for force or something. Okay, now it worked. All right. And now I just delete the executable in the root of C. There. Now this box is clean, and if I restart it, it will not have that message anymore.
So basically, these last steps is what an antivirus does.
That's what antivirus does, right? It would, if it recognized it, it would just have a list of how to clean it off. Right.
And also, as a quick and dirty analysis, let's assume I don't have Velociraptor. So
yeah.
Up to the step before the dumping memory part.
Yeah.
Could I locate that suspicious file even with Task Manager or MS-config?
Sure. Task Manager would show it, and MS-config would also show it, I think. It might not, MS-config might not, because it doesn't show all the runs. Auto runs is basically a superior version of MS-config. Yeah. And of course, if it was sneakier malware, it would hide from these things better. Yeah. But this is a simple case. These are good questions. All right, and no new questions in the Twitch.
Task Manager is all the processes that are running, so even
it'll be in there. It will totally be in there. But the thing about Task Manager, it'll show you all 1,300 processes. So it's hard to find the good one. That's why the auto runs is, the thing we used is better because it gives you the signatures. And therefore you can pick out the suspicious ones that aren't signed.